We are working on lesson 18-1, and this is what do you have to know in order to prove two triangles are similar? It's kind of like triangle congruence where we did side angle side, 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 but it's not congruence, it's triangle similarity. And so that's what we're going to be trying to figure out. What is it that we have to know about our two triangles in order to prove, in order for us to go ahead and assume that they are similar? So the problem situation is we've got a land boundary dispute between the national park and the landowner that borders the national park. The surveyors are working. They're trying to figure out the boundaries, and they're going to use similar triangles to help them get some of their measurements. Sometimes in the real world, it's just too difficult to measure the distance across a lake, or the distance between two mountaintops or something like that. So they use similar triangles to get those measurements that are too difficult to get manually. So they give us some information here about our triangles. We have triangle ABC and triangle DEF. These are the three angle measures that they want me to have. They want me to draw them so that they are not the same size. So I started off. Now we're not gonna do this one and this one. We're gonna do this one with the three angles, but I'm gonna point out why they didn't really have to even give me all three angles. Knowing two of the angles is enough, and I'll show you why as we're constructing it. So we're not going to do every little piece of this, but anyway, I have my document camera going, and I have my first line segment for my triangle. I made it be 8, and I believe these are centimeters. So I drew it 8 centimeters, and then I drew this one over here to be 10 centimeters. And I want you to understand that while we're actually physically measuring a line segment, you have to allow for a little bit of round off error. So when I was doing a practice one, some of my ratios didn't come out to be exactly equal, but that's because I had, some round off errors in my measurements. So be flexible. As long as our values are pretty close, then we'll be okay. All right, so they don't tell me which angle is 45, so I can make angle A 45, angle C 45, or I can make this one 60 and this one 75. It absolutely positively does not matter. I don't know what made me choose to do. I have a little bit of a glare on there. Sorry. Still have a glare. Okay, try to avoid the glare. Put the vertex at the vertex. Be sure the side is lined up. I think that lines up pretty good. Start at 0, travel around until you get to 45, and then put a mark on your paper. I'll do one on both sides. Now, I have where the angle measure is going to go. Those two little blue dots are really faint for you. But what I don't know is how long that side is. So I don't know how long to draw that out. I mean, it may end up being that side's short, or it may be that side's really long. I'll have to wait until I get at least one other piece of information about my triangle to know how long this side needs to be. So I just kind of drew it until it ran off the page. Okay, so this is my 45-degree angle. I'm going to go ahead and do this next one. Now, I'm going to go ahead and do C just because it's easy to scoot the protractor over to the other side and then do either one. I'm going to do, I either have to do 60 or I have to do 75. I just like the fact that I'm looking right here at 75, and 75 looks like it's going to be almost exactly where that line is. So I'm going to go ahead and use the 75 mark. Make sure. Okay, so 75 is right there. It's off the page on that one, so I'll just have to go with one mark. And line up the end of that line segment with that dot. And here we go. here looks like it's going to be point B. So I now have my triangle. This is my 75-degree angle. Now, they gave me 3 angles, but do I have to even construct this angle or measure this angle? Nope. It's made automatically by me drawing the 45-degree angle and then the 75-degree angle, and then where those sides meet, that's just what that angle is. Is there any doubt that that's a 60-degree angle? It shouldn't be, because 45 plus 75 is going to be 120, and you take 120 away from 180 and you get 60. So this is a 60-degree angle, but I'm not going to stop with just telling you it's a 60-degree angle. I'm going to show you it's a 60-degree angle. I'm going to measure it. So I'm going to go to the intersection of those 2 points, line my protractor up with the edge of this down here, and it is really close to 60 degrees. It's just, I mean, like I said, that's just round off. Oh wait, my 0. I wasn't down on my 0. Ooh, it's really close. If I adjust where my dot is, I can get it exactly on 60. But you can see that it comes out to be 60. Again, the fact that if I had been more precise using markers with this fat tip, or, you know, with the felt tip, it's kind of, if I was using a pencil, it would be more accurate because the pencil is finer. It's just what we call lack of precision. And the lack of precision is because of the marker. I go through the same process. Oh, and I'll also go back and measure that. I'm going to go through the same process. I'm going to draw a 45-degree angle. And on this one, I'm going to go a little bit faster because you've already done it with me. So there's 45 degrees. And the next one's going to be 75 degrees. 75 degrees. Okay, and then this is E. I'm gonna measure everything like it told me to. Be sure you measure the whole problem in the same units, so you can't start with centimeters and then switch to inches. So this one I'm having to guess because, you know, like, where does my dot? Do I put it in the first of my dot, the end of my dot, the middle of my dot? So I'm going to try to go to the middle. And I got that to be 9.2. I'm going to come over here and measure this one. Same problem. Where do I go? What happened? Where do I go? You know, where do I start my 0? I'm going to try to go kind of towards the middle of the dot. And that's going to be about 6.7. There's 6.5 right there, and it's a little beyond that. Okay, measured this one, and I go to the dot, try to go to the middle of the dot. That looks like it's 11.3. And then this one over here looks like it's about, it looks like it's 8.2. Okay, now I'm going to take these measurements and I'm going to go to my Springboard book and I'm going to write them in here. AB was 9.2. BC is 6.7. AC is 8. DE was 11.3. EF is 8.2. And I don't know why I have 7 right there. DF was 10. I made it be 10. I had 7 on my paper. I do not know why it was 7, because it was 10 units long. Okay, so now this is where I write my ratios, and I do my fat handwriting won't get inside that little box. So 9.2 over 11.3, and BC is 6.7 over 8.2, and CA is 8 over 10. And what's supposed to happen is, in order to prove that those are each equal to each other, you type those ratios in on a calculator and get a decimal value. And they should all be the same exact decimal value. Well, they're not going to be the same exact decimal value, but they're going to be close. So I had 9.2 divided by 11.3. And that came out to be 8.14. Okay, the next one that I had was 6.7 divided by 8.2. It's 0.814, that's 0.817. It's not exact, but it's not too far off. And then the last one that I have is 8 divided by 10, and that one's exactly 0.8. So they're very, very close, each one of them. And again, that's the inaccuracy is simply due to the poor precision of my instruments. So it says, do you think that the three pairs of congruent angles guarantee a triangle similarity? Yes, it does. If the three corresponding angles are congruent, your sides are going to be proportional. And it has to do with, let me draw this other picture real quick and I'll show you. It has to do with this. I could have drawn my picture like this. I guess you want to see. I could have drawn my picture like this and made this a 45-degree angle. I'm just pretending that I'm making it a 45-degree angle, okay? So I could have this first triangle right here. This is a 45-degree angle. And if I put my my mark in here sideways, I could have made sure it was a 75-degree angle. But anyway, so this triangle is similar to this bigger triangle, is similar to this bigger triangle, is similar to this bigger triangle. So all we're going to do, and I got them evenly spaced, it doesn't have to be evenly spaced. Each one of those bigger triangles is proportional to any one of the other ones. Their side lengths will be proportional, and their angle measures will be the same, okay? Because these lines right here are going to be parallel lines. That's going to be a transversal. Those are going to be corresponding angles. So it's all just the main thing you got to remember is that for similarity, you got to have congruent angles. So on this one, it's talking about, okay, what if they just give me two angles? We already talked about that. The fact that you only give me two angles, that does not change the measure of that third angle. Having those two angles guarantees that those third angles are going to be the same. So the bottom line is, it's saying right here that so it says the investigation you did suggest that angle similarity postulate for that there is an angle similarity postulate for triangles, and there absolutely is. So very much like, okay, so I want to remind you, I want you to think for just a second. Think about triangle congruency. Okay, we did side angle side, we did side side side, we did angle side angle, and we did angle angle side. And I think you also did right hypotenuse leg for right triangles only. Okay, so these are postulates and theorems that we figured out. So in order to prove two triangles that are congruent, triangles have 6 parts. They've got 3 sides and they've got 3 angles. You don't have to identify all 6 pairs of corresponding parts congruent in order to prove the triangle's congruent. You just need 3 parts. Okay, and once you know any of those 3 parts, the other 3 parts that you didn't name have to be congruent. That's CPCTC. So this is saying that for similarity, okay, we don't have to have 3 pieces of information. We just need 2. We need to know that we've got 2 pairs of corresponding angles that are congruent. If we have that, then we're going to have two similar triangles. So two congruent corresponding angles will guarantee that two triangles are similar. And what similar means is that, so therefore, proportional sides. So that's what we've learned right here. It says for these two triangles right here, do we have enough information to prove that they are similar? I would say no here. Well, I would double check. Hold on, double check. We've got a pair of congruent angles here, okay? But we've got this angle up top, and then we've got this other angle. So we may have to do a little calculation. Let's see. What do we get if I add 110 and 45? 110 plus 45 is 155. Take that away from 180 and you're left with 25. So this angle up here is 25. And then if you do the same calculations here, you get 140, take that away and you get 40. So you don't have two pairs of angles. No. Do not have two angle pairs congruent. What about this one? Now don't jump real quick and say no. They each have a 90-degree angle. So we've got 90 degrees here and we've got 90 degrees here. So over here on this one, we've got 90 and 35. That goes together and makes 125. Take that away from 180 and you've got a 55-degree angle right here. Okay, so on this picture, we have a 90-degree angle, a 55-degree angle. Is there any way this one right here is going to be anything other than 35? Absolutely not, because when you add 90 and 55 together, it's going to give you 145. You subtract that away from 180, it's going to be 100. It's going to be 35. So these two triangles are similar. You're going to say yes by angle similarity. You've got two pairs of congruent angles. And then based on where the congruent angles are, you can determine your similarity statement. Now these triangles are not named, so I can't do it. I'm going to go, this video is running a little long, so I'm going to stop before I continue to do number 4. There will be a part 2. See you